experts who have joined with us today are Director CSIR Cbri, Dr. N. Gopalakrishnan, Dr. Mangesh V. Joshi, MD and CEO of Sanrachna Structural Strengthening Private Limited, Engineer Romel Singh Jamwal, Ex-Director Conservation Archaeological Survey of India, and Dr. A.K. Mittal, Chief Scientist CSIR Cbri. So let us begin with our talk on conservation and restoration of heritage structures by CSIR Cbri. We shall start with Director Cbri, Dr. N. Gopalakrishnan, who is an expert in structural dynamics and earthquake engineering and experimental methods in structural engineering. He is MTech from IIT Madras and PhD from Indian Institute of Science, Bangalore. Dr. Gopalakrishnan has been credited with the prestigious Ramaiah Prize for the best publication.
I think you can stop.
Yeah, so I request now Director Sir to kindly address the participants and deliver the opening remarks for the session. Over to you, sir.
Yeah, thank you, Shika. Your work very well done in the last, I don't know, 4 or 5 months or even more, almost like 7 months. If I could guess it right. So you have been going, and this is the second turn of CSIR Cbri, which has come. We are very, very thankful to you. And previously, Gita initiated this. We are following it up extremely good. This is a very, very important kind of discussion that we are going to have. We will have here none other than Jamwalji with us. And then Joshi also will be here. Mangesh will be here with us. And we have a couple more I see here. And Dr. Achal Mittal has been spearheading this mission mode project on heritage. A lot of work got done at that time, and then we are continuing that right now as a center of excellence in heritage in the next few years to come. All this is because of the hard work of that group. I will stop now, right now here, and then we will go ahead with the presentation as well as the panel discussions. My thanks to again Jamwal Sab as well as Dr. Mangesh. Thank you.
Thank you very much, sir, for the crisp opening remarks. So now this is to all the friends who have joined online. You may please post your comments and queries in the chat boxes. We shall be taking those questions at the end during the discussion. So moving further to the speakers, we have Dr. Achal Kumar Mittal, Chief Scientist from CSIR Cbri Roorkee. Dr. Mittal obtained his BE in Civil Engineering from University of Roorkee, which is now Indian Institute of Technology Roorkee. MTech from NIT Kurukshetra and PhD from IIT Roorkee once again. Dr. Mittal has also obtained PG diploma in earthquake engineering from Japan. So the main research areas of Dr. Mittal are earthquake engineering, wind engineering, and heritage structures. He has recently completed a major CSIR mission project on heritage structures, as Director Sir told. He has acted as project coordinator, having multidisciplinary scientists from 7 different laboratories of CSIR. So with this, I invite Dr. Mittal for his talk. Over to you, Dr. Mittal. Sir, please unmute.
Yes.
You have to unmute. Achal.
Yes. Can you hear me?
Yes, sir.
I can hear you.
Yeah, please carry on.
Thank you, Dr. Shikha. And really, we are at CBRI. We are working for quite some time on heritage structures. But thanks to CSIR for taking this up in a webinar mode, and reaching out to public, students, and all other engineers, fellow architects, engineers, academicians. So this is a great opportunity for us. We are thankful to our panel discussion participants, not to mention Dr. Gopalakrishnan, the director of the institute, but our very senior archaeology friend Jamwalji and my close friend Dr. Mangesh Joshi. So I think my screen is visible, Dr. Shikha. Okay.
Yes,
so what we are, I will like to mention briefly about what CBRI basically had been doing. And CBRI has contributed to the conservation and restoration of CBRI many ancient monuments. Mostly these projects were in collaboration with Archaeological Survey of India, but some of the projects were in collaboration with other agencies or state archaeology departments. So you can see Taj Mahal, Sun Temple, Konark. We are still working partly on some part of Jagannath Puri Temple and Chittorgarh Fort, Qutub Minar, Amer Fort, and many more. So we have also worked not only on monuments, but also on very recent type of heritage structures. If we try to go by the definition of the heritage and monuments, so Kashi Vishwanath Mandir, FRI building Dehradun, UP Vidhan Sabha, Rashtrapati Bhavan, Old Delhi Railway Station, and World Heritage Site of Chhatrapati Shivaji Terminus building at Mumbai. So Cbri is doing these kind of things. But what we have found from engineering point of view, basically, that there are many challenges when we try to address this. Like many a time, exact layout plans, section, material details, they are not available when we try to handle these kind of heritage structures. Restoration material compatibility, because these were made many years back. So what is the compatible material today, or we have to come up with those materials? We had a lot of exchange of idea with many of the conservation architects and conservation engineers specialized in this field, how to do it. And engineering wise, we have to test it, whether the compatibility exists. Huge thickness of a structural element having one or more type of material is also encountered. Many locations are inaccessible in these ancient structures. Limited opportunity for testing, at least NDT is available, but even semi-destructive testing, cutting course, etc., many a time is a challenge, and we do not want to disturb this. So it becomes very difficult for engineers to address the structural and material issues associated with these kind of structures. And we have even uneven surfaces with carving. So many of our techniques which are available for non-destructive testing are sometimes very difficult to apply. So with this background, having major challenges in materials and structures, and with the forthcoming further challenges with the digital technology, we have identified research at CSIR under mission mode project, like this classification, digitization, structural analysis and diagnosis. Hybrid NDT is a place where we really progressed well, this group. Environmental aspects, there were other labs also coordinating, like NEERI with us, material development and restoration technique. So these were the areas where we had small leads which we could do during this. CSR, I will only like to briefly present here that we have done a UNESCO World Heritage sites, some of the work. Primarily it is on Konark, where structural safety using latest technologies, laser scanning, GPR, endoscopy, and we will try to use whatever the state of art facilities are available with us to understand the behavior of the material and the structure and try to provide solution as per. This was a project by Archaeological Survey of India. We have also provided solutions in CSTM building after a detailed study on the cracked stone pillars and strengthening of conical dome, keeping the architecture of the building intact, and development of biomolecules that can remove and inhibit biofilm from the surface. Design and development of photosystem protection against a nocturnal insect was developed by one of the labs to be implanted at our other site of Ajanta and Ellora. In this project, we could develop 7 technologies, but we could transfer 2 to the commercial level. One is for nanolime for heritage structure. Another is imaging of defect using ultrasonic pulse velocity. I will leave you with some pictures. This is the FRI building project which we are doing, and our recommendation are in the process of being implementation. This is a brick masonry building of nearly 180 years old, and you see earlier on the left side you can see the stones were like this and they were cleaned, the masonry wall and the cracks. So with these small introduction about the CBRI initiative, there are many more. I thank you all. Over to Dr. Shikha.
Thank you very much, sir, for giving a brief overview of whatever activities going on this kind of conservation of heritage structures at CSIR CBRI. So we'll move to our further speakers. Next speaker is Dr. Mangesh Joshi, who is the MD and CEO of Sanrachna Structural Strengthening Private Limited. Dr. Joshi, a principal civil structural engineer and the founder CEO of Sanrachna, is leading the company in structural repair and retrofit. He completed his PhD from Department of Civil Engineering, IIT Bombay, in the area of structural retrofitting, including heritage structures. So I invite Dr. Joshi for his initial remarks. Over to you, Dr. Joshi.
Yeah, thanks a lot. Thanks a lot. Am I audible?
Yeah.
Thanks a lot, Dr. Shikha. My mentor guide, Dr. Achal Kumar Mittal ji, Director CBRI, Professor Gopal Krishna ji, and respected conservationist Jambal ji. It's been my great pleasure to associate with CBRI for two of the project, and I always like approach of Dr. Mittal in that case, because he said that, "Bhai, hum to scientist hai, we will make something, but you are the actual applicator. You are actually applying at site, and we should ensure that whatever we are developing is equally workable at site." So that's why it's always a pleasure discussing with him with different issues and different solutions. When it comes to conservation, I feel being a engineer, coming from engineering background and doing conservation, I think there are two aspects. One is always on our mind, being structural engineer, is the stability. That is utmost how to maintain the stability. But with heritage, it's conservation angle and how to maintain the existing beauty. That is also a challenging. And
sorry to interrupt, sir. Dr. Mittal, can you please stop sharing? It will be helpful.
So it is always trade-off that whatever strengthening or stabilization methodology we will come up has to be compatible with its aesthetic. So that is the most challenging thing, and that's where I feel that collaboration between institute like CBRI and people like us who do actual site application matters. To tell you, we work for two projects with CBRI. One is Rashtrapati Bhavan. That was again a very prestigious structure, and there we need to ensure that we are restoring safety and beauty both. And CBRI really came up with innovative approach in terms of materials for lightweight concrete and how to make it compatible with old lime concrete. And not only that, by introducing different 3D LiDAR type of technology to capture the complex geometry of the building, because otherwise it's very difficult to get that building. So CBRI really help us in assessing those things, and because we are also new in that, so that was a good handholding from their side to guide us in different material compatibility aspect and to get the data, authentic data from the existing building, because as he rightly said, we don't have much data available with us in terms of drawing, design, and second project which we are currently working with or in planning or we are going to do is this dome of CST or Chhatrapati Shivaji Terminus or CST station. There also it is an interesting case because dome is in dire issues of structural stability, means there are severe structural crack, and again there was a lot of challenges. There's the involvement of heritage committee, which again look at beauty are part of it. Again, we have to ensure stability. But finally, again, through a lot of deliberation, from a lot of input from all the stakeholders, we could finalize what best can be done. and we'll be working on that. So that way I feel that CBR and all the premium these national institutions in research are playing major role, and I think they should keep involving people like us who are actually working at site, and together we can create wonders and safe and beautiful structures going ahead and really conserve our heritage. Thanks.
Thank you very much, sir. So very correctly said. Together we can make wonders. So definitely industry partnership is very important for any ground application of any academia or research. Two more very interesting topics you have told here will come up after our next speaker's talk. Our next speaker is Engineer Romel Jamwal, ex-director of conservation from Archaeological Survey of India. Mr. Jamwal did his graduation in civil engineering from Institution of Engineers, Kolkata, and masters in conservation studies from University of York, UK. He has more than 30 years of experience working in conservation, development and management of historic buildings, monuments, and World Heritage Sites with ASI at national and international levels. So I invite Mr. Jamwal for his initial inputs. Over to you, Mr. Jamwal.
Thank you, Dr. Sikha, and good afternoon to all co-panelists and all the audience. And as you know that ESI is the nodal agency in the country, nodal department who is dealing with the heritage structures, monuments and historical buildings, and has a great role to perform and set standards and guide the whole heritage conservation process in the country. But unfortunately, we don't have that much of technical strength with us. So we are trying to fill the gaps anyway by taking the recourse, taking the help of Cbri and other leading institutions in the country. And in that way, we are very successful by collaborations with the Cbri. I think the maximum collaborations we have done so far are with the Cbri, and for quite a number of monuments, the Cbri has produced the studies and shared with us their technical know-how, and that was quite useful. But I would say that this heritage area for the civil engineering input, for the technical input is a totally different. The mainstream is going on in the mainstream main channel, and they think that yes, we are equally expert and handle the heritage also in the same fashion. But it's not like that. It's absolutely different until and unless you have a mindset, until and unless you are oriented towards that, your work will land into criticism. Somewhere it will land into the criticism. And when you will touch a monument and do the intervention, and if it's not going with the, as the Dr. Mittal was telling, the compatibility of the materials and the selection of the interventions, selection of the input. So if it's not going with the heritage structures, means if you are disturbing the authenticity of the originality of the, say, 1,000 years old building, 2,000 years old building, 1,500 years old building, then everybody will criticize that. And that is a big challenge of deterioration of the materials. Materials are deteriorating from, say, so many centuries together. We, the civil engineers, are much accustomed that 100 years building is over. But that's not the case with the heritage structures. So demand is quite wide, quite large. Awareness needs to be created among the professionals, among the leading institutions. Not only the wait for this assignment of the some project from the some department, maybe state or center or some another PSU, but if they make a part of some development of something from their side, say the core material, the core material which is the binder, which is being used, say for the years together, 2,000 years old. The Romans has constructed all those structures, the Colosseums and the aqueducts 2,000 years back, and they are standing till now. So such a lasting material. But publication do we have, or the Cbri have, or the BIS have so far, which we can share with the country and even guide the layman that yes, this is something, and you can go ahead with these kind of guidelines. The biggest challenge is that the hydraulic line which we were using in the past, in the construction past, is not used in the modern times. It's absolutely nowadays it's a rich in calcium oxide. It's a non-hydraulic type of thing. So the scenario has totally changed. And then availability of the binder in the market. Everybody starts that he's expert in the lime mortar and then this and that thing, and even he may be bringing some stuff from as a ear slacked or something powdery stuff and then mixing and then saying that this is also a mortar. Similar is the case with the pozzolanic materials. So no standardization is available so far. Nothing is available. Even the BIS is working. They have constituted a subcommittee. I don't know the CBRI has a representation in that. Discussions are going on to bring out something good on the lime and lime use and handbook on the lime also. But I previously, when I was directly functioning with the ASI, I suggested that the participation from the leading institutions, academic institutions, should be ensured. But I don't know that some representative from the CBRI or some other leading institutions are landing there, and then they should contribute very, very sincerely and very deeply, so that not only the ASI, not only their small wing towards the heritage, but as a country as a whole uh, can benefit from those kinds of things. That's the basic need. The basic need is the characterization of the materials. So it's what kind of properties they have. If you are, as Dr. Mittal is telling, if people are telling they have touched the Rashtrapati Bhavan, it's a very recent, says about 100 years. What about the Konark, 1,000 years old? What about the further south, maybe 1,500 years old? So if you are going to select a, say, stone or brick, so compatibility will be if you are going with a matching with that material. So matching with the material means properties. Maybe you have to start with something. So no data is available. And ESI don't have that much of a capability for characterization of all those materials, or have some booklet on that. This is the work of the leading institutes in the country, leading engineering colleges, leading research laboratories who can do something for the heritage. So it's a very, very wide scenario where not only the binder, the materials characterization, then further go inside structural stability. What else? What we have done so far for the seismic stability, retrofitting. And retrofitting, you can't do the same thing with the booklet available for the modern structure. You can't implement even a single percentage. You can't implement from that on the heritage structures. I have seen that in the Bhuj earthquake. That a lot of recommendations were coming with that handbook that implement, but at the site it was nothing was implemented of that sort. It cannot be. It will totally change the look. So something about the retrofitting, something about the seismic stability, something about which are the very crucial structures, say minarets, or some elements in a particular building. Nothing much has been done so far in that direction. Then go further about the geotechnical investigations. So anyhow, we were concerned something about the Konark. So CBRI has come up with the recommendation that don't worry, it has a very good foundation. It's standing on a rocky strata and the sandy strata. So there's no such issue of geotechnical instability or something wrong with that. But there are challenging structural issues and structure. Dr. Mittal knows it very well that despite of our efforts in the Lingaraj, in the Jagannath temple, we landed with the steel frame, which may not be that much appropriate in that structure. And later on, to hide that the frame, what we have done, we put the cladding without any again putting into that scale in front of the committee or something, because initially we were reacting to that this steel frame may not be compatible, because for the Lingaraj, if any one of you have interest, they can go in the Lingaraj, they can see some supporting system in the stone masonry has come, which is still can be said is going with the heritage structure, but not the absolutely new steel frame in front of stainless steel frame in front of the Lord Jagannath. And then good sense prevailed later on, though in a very hidden fashion. And then the cladding has been provided. I was telling, or we were telling, that this may be a sort of a redundant and non-functional kind of thing. So to verify that, we paid quite a good amount to the Cbri also, and put there a system of checking how much load is coming over that. And I think that Dr. Mittal can highlight more on that, that so far we have not seen any significant load is getting transferred to the steel frame, but not have been done to show it the functional one. Maybe taking the recourse of some badges or something, something like that. So challenges are widespread, huge challenges, very wide area. And some lead can be taken maybe from the European countries where this industry is going on in parallel with the modern construction, and design and development and literature, everything is coming up in that scale, but not in our country so far. So I would say and request to the all professionals and audience that please think over on this side also, and don't take it straight away for granted that this mainstream engineering and the conservation field is the same. It's diametrically opposite, and your challenges are appreciated only when it goes in a very befitting manner. And I can quote you that if somebody has to see how in a better way the intervention can go, that the bridge connecting this Red Fort and Slimgad Fort, or the two spans we have strengthened, put the retrofitted that, and it's operational now. There you will not find where the strengthening, how the strengthening has gone, and where is that? No props, no frame, no store, so that kind of thing. It's very much inbuilt kind of thing. So something, it's just, I'm quoting one example, but something that should go, which goes with the structure without harming its architecture, its elevation, its basic properties, its basic values. So I think that's what I was thinking to share with you. And yeah, I request that.
Thank you, Jamal. Thank you. You have opened up a Pandara. We were thinking to open it up during the course of discussion, but you have opened up, and I'm not sure that how many students, because the people, they do not know, many people attending online may not know that much about our Lingaraj and things. So we have to unfold things, but your points are well taken, that efforts are being made. As Director Cbri has already told, we have already established a Center of Excellence in Cbri with the support of DST, and some basic issues from the material point of view and other modern technology use in heritage buildings conservation, as well as the popularization and how to use modern techniques, be it heritage BIM or be it sensor-based technology, are being done. But you are very right. This is a very challenging field. I will not say it is diagrammatically opposite to the engineering, but I will only say that this is much more challenging because the basic material properties for concrete and steel we know, and brick masonry we know, so we can analyze it. But when we talk about these materials, as you rightly mentioned, 2,000-year-old, 1,000-year-old, our challenge is geometry, material, compatibility, seismic strengthening with innovative ideas, and whatever strengthening you do, it has to merge with the architecture. So we have to take everybody together, including the conservation architect with us, material specialist, and all electronics, instrumentation people. So over to Dr. Shikha, please take it further. I thought it is good to conclude, Dr.
Yeah,
Thank you.
Thank you very much, Mr. Jamwal, and thank you, Dr. Mittal. So thank you for the initial remarks. We'll now move to the discussion session, and I keep this forum open, and I request Dr. Mittal to help me and to steer this discussion session.
It's okay. I have already.
Yeah.
You are wonderfully well, Dr. Shikha. Please ask.
So, let us begin. I would like to know from our industry partner. So, what are the modern tools and techniques that help you during this process? So, Dr. Mangesh, if you can, what modern tools or techniques that you use?
Can you hear me?
Yeah, we are here. We are hearing you. Yes.
Okay, video नहीं आ रहा है क्या? Might be some
video
issue.
नहीं आ रहा है. Yeah.
Some might be some issue. I don't know what.
Okay.
what issue. Suddenly it got okay. I'll re-log in. But to answer your question about modern tools, means all our old structures are quite intricate, and those when those are made, we don't have this blueprint or original drawings available for them. So nowadays, like what help us to, and if you want to reproduce the data in the same way, it's very important that we know the dimension. So in our case, I will cite the example of Rashtrapati Bhavan. This 3D LiDAR technique really helped us. This 3D LiDAR helped us in reproducing the dimension. I think Jamwalji might be knowing better than us that are they using it for archaeology purpose also to reproduce the original drawing, or Mittal Saab can also further throw light on it. But this time we exhaustively use it to get a dimension, because every petal is unique, and reproducing that petal, it was quite challenging, and manually it would have been quite laborious and time consuming job. But then with the help of 3D LiDAR, it helped us a lot. And second part is like in terms of material and electronics and electrochemistry of it. Like in entire Rashtrapati Bhavan, though it looks as a completely masonry structure, it has steel also in Chajja, and it was corroding. And I think first time we'll be using ICCP, impressed current cathodic protection, in that means to protect the reinforcement inside it, and that is a quite a unique way, and everything will be hidden, so we are not compromising on its beauty part also. And thirdly, in terms of material compatibility, like we talked about CST station, that the material which was used was a soft limestone, and if we put anything metallic in that, that was initially they were thinking anything metal, it would have added a lot of stiffness to the whole thing, and in Mumbai environment again it would have been corroded again. So instead of that, we went with non-metallic carbon reinforcement with inorganic mortar, means not, and it was a backing material, it was not a fascia. So with use of inorganic mortars and this modern reinforcement, we could really give a good solution to the whole problem. So in the whole process, we were interacting with Cbri about the selection of material and system and compatibility. So that way, it was a great help from their side.
Okay, so this takes me to the next question. How is it working with a research institute like Cbri? So what are the expectations that you have when you work this our institutes?
Yeah, we always say that we need to have a lot of patience working with heritage sector also and working with Cbri also. Working with scientists, we need to have patience.
Yeah.
I also come from that background, so I can understand. So what I feel that they are, I think they are, unfortunately we have too few institutions and too much work. So everybody's overloaded, and taking prioritizing the thing for everyone becomes really challenging. So out of that, getting and it's good that they don't give scheme in haphazardly, like they take their time, they complete their thought process, and then only they deliver it. So I appreciate that, but somewhere we need to think how to cut down on those points and create sub centers and sub center of expertise and close coordination with sites. That's what I will say. Retrofitting patience is always required, so we can handle that.
Thank you so much. Thank you so much. So I'll come to Dr. Mittal now. Sir, can you please elaborate some stories about the conservation sites, like this is that terminal that you said, and the Konark?
Okay. Actually, that's a very loaded question, but there are some of the very good takes. But this was a challenge. You know, I will like to add to what Dr. Mangesh has said about Rashtrapati Bhavan. In fact, there is a team, and all groundwork has been done by IIT Madras, Dr. Radhakrishnan. He did for their Chajjas. We are part of the committee who is overseeing it. Jamwalji also 2-3 years back was part of that committee. He on the Rashtrapati Bhavan Chajjas. So the modern technique, what site is using, and he has already mentioned about the 3D laser scanning and impressed current method, cathodic protection, and other things. But my colleague, Dr. Devdatta, I think is there online, is also using many of the NDT techniques. We are using drones now for our inaccessible location mapping, and we are using many kinds of wave. If I don't know whether I can pull in Dr. Devdatta is there. Dr.
Yeah, Dr. Devdatta, you may join, please.
Yeah.
Yeah. Am I audible, sir?
Yeah. Yes. Please tell what are the modern image processing technique you are using.
Right now, sir, we are working on different kind of multi-wave based
you may please
techniques,
turn on your camera,
like electromagnetic wave based or ultrasonic wave based or different GPR, ultrasonic tomograph, different commercially available equipment, along with the new development of algorithms, which is allow us to do a automatic detection of different buried object or different anomalies inside the heritage structures or different layerings to understand the structural system. All those things we need to do using the NDT techniques.
Yeah,
so,
Dr. Devdatta, I think what we want to impress upon to our students and all other fellow architects, engineers, and participants in this webinar through live medium, that whatever modern techniques of science are available, we are trying to use it for characterization, for geometry, and for assessment of the health. Is that correct, Dr. Devdatta?
Correct, sir. Even, sir, we are going towards the health monitoring, heritage health monitoring, where we are using different kind of sensor and sensor networks, like for say strain monitoring, acceleration, displacement, as well as tilt, many type of health parameters we use to monitor. Even we monitor color fading, noise level, etc. for heritage structure using fiber optic sensor, vibrating wire, or electric based sensing techniques. So different kind of monitoring technique. Recently, we've also started using drones for the remote monitoring of the structures, using thermal imaging as well as visual imaging, and creating a 3D map and to monitor with the time how it is deteriorating or something like that. So all this new technique we are trying to exploring, where we are developing algorithms at our own. We are developing towards the equipments also. We are trying to incorporate robotics also into this, so that automation can be done. So all these things we are working on, sir.
Yeah, thank you, Dr. Devdatta. Thank you for helping me out in answering this question. Regarding the challenge of the conservation stories, right now we are associated with FRI building where work is going on. So, and we did for Kashi Vishnath Mandir. So there were, it is not, they both of them are not ASI monuments, or they are not under ASI protection. But the challenge for there is half the time it is technical, but sometimes it is non-technical also, because we have to keep the local sentiments, the sentiment of the pujaris, sentiment of the bhakts, and all other thing, and the timing, the constraint of the timeline for the executioner. So it is more difficult for people like Mangesh Joshi. We only recommend. We have recently completed recommendation on our Mahakaleshwar Mandir Ujjain, and they are under city development plan. They are going to take up, maybe they will take more, they will involve us more when the implementation comes. On the Sun Temple Konark, where I and Jamwal Saab visited together maybe more than once, we had a tough time to work at 45 degrees centigrade temperature, and then Jamwal Saab asked, okay, you go check, and we were together in to climb this 8-story high building, something like this. 8 to 10-story high is the Jagmona of the Konark temple, and we had to convince along with Jamwal Saab, even to the Secretary Government of India, that we are going to cut some course from the Jagmohan, and then somehow with the help of Jamwalji, we could get that permission. We could test the foundation system, and now we can say with confidence that foundation is good. So that kind of challenges, we have enjoyed those challenges, and we are still hoping that more and more challenges come, and we can do whatever best we can do in our lifetimes for the heritage monuments of India.
So it is quite impressive, sir, and whatever informed by Dr. Devdatta, the drone survey and robots and use of sensors. So you have touched my area of expertise also. So yeah, I was about to ask about the structural health monitoring process, the crack monitoring, the progress of cracks. So mostly sensors are used wired and in wireless forms. So I just came across one of the program that CBRI has been doing for students. So Mittal sir, if you can elaborate on that program.
Oh yes, we in the mission program we did this idea actually training. We thought that there are so much of heritage monuments. Even in every city, you have 2-3 heritage structure. ASI alone cannot maintain all. Number one. Now, number two, we need to create awareness. Even today, our team has gone, 2 or 3 architects have gone to one place where a society is managing a heritage structure, and we are trying to study how they are managing because government has limited resources. Keeping these two things in mind, we had a discussion in our mission mode project with our director, Dr. Gopalakrishnan, and our team members like Devdatta Ghosh, Siddharth Behra, and others. We were thinking what we should be doing to create more hands, more heads to work toward this problem. So the best was to engage students. So we devised a training program. In fact, the name was also given by our director, Bhagwan a Search. So Bharat, Grandeur, Heritage, and something like this, he created an acronym for us, and it went really great successful. We organized 4 training courses, physical, in 4 parts of India, in north part, in west part, in south, and in the east, in all our laboratories like NCL Pune, CSIR, SCRC Chennai, and Kolkata lab. So we use our labs resources because it's a CSR project. We used it, and many students participated. We put them, gave them project. Our team guided them, and then they submitted, and our director gave away a few awards to the selected entries who were adjudged. There was a system. So this motivated students, and they are still, some of them may be hearing us today because they have a bond with CBRI, all these students. So this was a special course on heritage structures.
So is the program still going on, or any?
No, we will take it up in the next next year.
Okay. So now next question comes to you once again, sir.
Yes, please.
Yeah. So how is it to work with industry partner? We had the other side.
No. It's okay. Industry partners, they always ask us to expedite, and it is very good. They even come up sometime. We gave them solution which may be, especially when the structural retrofitting is there. So we gave them solution. Sometime it is not that practicable. So they tell us, sir, kindly make it more simple because on site it becomes very difficult. So we sit together. Come out from our academic solution to the field implemented solution, but it is very good thing that CSIR is doing hand-holding with many of the applicators or industry partners, you can call them. In CBRI, we have many fields. People are working. Repair and retrofitting of buildings even is a great field for us. So they are good. So they come up, and they try to join hands with us. They feel that once they join hands with CSR lab, their name also goes up, and they get better recognition of their work also.
Thank you so much. So now, since Mr. Jamwal is here, I will not leave opportunity to ask him questions also. Sir, how are this archaeological site, this heritage sites identified? Other than the list which are already existing, how do you add on to these sites? Is there any regulation, rule that you follow for doing this?
Yeah, that is, see, this department is Archaeological Survey of India, and we have in our department, besides the engineering wing, archaeological cadre, who are expert in study of archaeology and bit of architecture and a bit of structures also. So the assessment goes for its archaeological value, its historical value, its architectural values, its aesthetic values. So all these merits, and plus the yardstick of that building should be at least 100 years old. That's the basic minimum. And in addition to that, it should be have a national importance of archaeological importance, historical importance, architectural importance. So 3-4 parameters plus this boundary of 100 years. If that those things are satisfied, definitely that building comes into the list of our monuments, which are presently around 4,000 in the list of ASI declared as a nationally protected monuments.
Oh, that's
I think, Dr. Shikha, to add on, there are, to best of my understanding, Jamwalji can correct me, there are more than 36,000 of monuments we are still waiting with ASI, and list is growing. India has a dearth of monuments. That is why we all institutions and public should come forward to preserve our heritage, whatever is needed to be preserved. So there are many monuments. There is a list.
Yeah, so totally it's a huge number.
Yeah,
huge.
Yeah.
So, sir, other than the activities of ASI on its own, what are the areas where ASI need to collaborate with academia or research institutes?
Areas in addition to what I said in my previous sharing, I think that to contribute more towards the heritage, more use of digital tools is needed to be seen and worked out. What digital tools can be used for assessment, diagnosis, or any problem finding purpose on the heritage structures. The use of entities, popularization of the entities. People are not aware about the still, as the Mittal Sahab was telling, that we were trying to take out the sample, physical sample. Somewhere it's needed also, where only you can rely upon the physical. But if entity can work out something, give you some lead, give you some indicator, because these are very handy tool of the entities. So popularization of the entities, and then the use of AR and VR. VR means some, see, in the monuments, in the heritage structure, there may be some elements which are standing, but there are some missing, and how they were contributing for the structural stability or how their restoration can be done. There, the use of AR VR can be of much useful. We can create three-dimensional images beforehand. We can discuss across. We can discuss with the various people and then see how that will be, and then how that can put to the stability. So challenges are wide open. In addition to these structural, this seismic, geotechnical characterization of the materials, I think the three more I added: that entity, the AR, VR, the digital use of digital tools, drones, use of drones, etc. See the assessment of the wide areas. Like we are working at the Angkor Wat also. It's a huge complex, biggest temple in the world.
Yeah.
So even without the recourse of the drone technology, it is not possible to assess the extent of even the temple. Its moats and its tiers of boundaries and the structures. So there are bigger complexes also. So the use of drones also. So these are 3, 4, 5 areas which are the high technical kind of things, which ASI doesn't have that much of establishment. In addition to the basic one, what I told about the materials and its problems, structural problems, and the stability problems, and its stability against the dynamic forces, soil stability, etc. And who doesn't knows about the challenges daily recalled at the Taj Mahal? Somebody is saying the Yamuna level is going down. How it's affecting the stability of the Taj Mahal. Somebody is saying that it is standing on the wooden piles. It says the theories are coming from their own. So somebody needs to, and then the yellowing of the marble, pollution, effects of the pollution. So, but not. it's a long list. Long list means it needs to be not only that's I told that only the collaborations, because sometimes the government departments only collaboration does not work. So somewhere if the institutions can go by their own, something can do, that will be more useful, not only for the Taj Mahal, the similar things, white marble monuments which are protected or not protected. These things can be implemented at those sites also. If something, some literature is available that how to go with the say pollution or yellowing of the marble or the variation the water tables or something like that.
Okay, thank you so much, sir. So it's like you need to follow some regulations also for the conservation of this kind of heritage sites. So can you elaborate on this thing?
Why not? It is, we have to work within the prescribed parameters.
Yeah.
So first and foremost is our conservation policy. It's available on the ASI website also. So do's and don'ts are well prescribed over that. So you know that we have around, as Mittal Saab told, that around 4,000 protected monuments, and huge numbers are waiting, but that's not in a list so far. We are much bothered about the what are in the list. So out of that, around 22 direct under control are the World Heritage Sites under the ASI, and other cultural 7 or 8 which are protected by other departments. We also render some technical advice whosoever requests to us. So in addition to our conservation policy, the UNESCO World Heritage Center has its conservation charters, Vanish Charter, Vara Charter, or the UNESCO World Heritage Center Charter. There also the do's and don'ts has been prescribed, that what to do, how about the materials, how about the restoration, what to restore, what not to restore, how the originality has to maintain. So all these things has been well prescribed, and we can't go. And similarly in the use of the materials, similarity, compatibility, and restoration, and then the maintaining, using the workmanship of that character, that quality. So all those things has been prescribed, and we have to go within that parameters. That's what I was telling, that there is a big difference between the modern engineers who are well aware about the modern technologies, modern materials, but maybe something, maybe they not be much oriented towards how the use of historical materials and how the restoration has to be done of the past buildings. Okay. So the system has been well prescribed.
Okay. Thank you so much, sir. So we are running out of time. I'll take a quick question with Dr. Gopalakrishnan, Director Cbri. Sir, are we connected? I think sir is busy.
Yeah,
so...
give me a minute. I'm here.
Sure, sir. Sure, sir. Sir, when it comes to the safety of structures, so you are an earthquake expert. So can you have some comments on how this earthquakes and safety of structures are performed?
Shika, let me put it this way. It's not only earthquake. I'm just summarizing the wisdom of Jamwal. I will put it in a category called as climate change effect on the heritage structures. When you tell that the water table is going down suddenly, and when you are telling that the pollution of the marble is calcium carbonate, and it is being acted upon by a river, with the rainfall, with the sulfur dioxide in that, and whatever be the carbon monoxide in that, and all those things. So one single kind of parameter, which is going to be a death knell for some of these heritage structures, could be the climate change. So lo and behold, we need to take care of that. We need to take care of some of our heritage structures, not necessarily Taj Mahal, lots of heritage structures, including what Achal mentioned, Konark, number of them. The 30,000, 40,000 list of heritage structures, even in a single state like Tamil Nadu, has got 50,000 to 60,000 structures in a district called Tanjavur. So that's a kind of effort that it has gone on to that. And kindly understand, in engineering, let me take the 2 or 3 minutes more. In engineering, we do what is called as a topology optimization. That actually means that we find out the stress flow of a particular loading condition onto a material and keep removing some of those materials such that you have the topology or the geometry optimized to the maximum. That's how your bones is a kind of shape, the shape a bone possesses. Why it is like that is a reason because of the naturally evolved topology optimization. But the heritage is something slightly different. The structures or the materials that you use for heritage is something different. Here, materials do not form a important thing, or the cross sections also do not form a role. It is a geometry that forms a role. So this is something very important. In a classical civil engineering, when you take a arch, which is parabolic, and if you have 2 hinges or 3 hinges, and you apply a uniform distributed load, neither you develop a bending moment nor a shear force. That means you don't develop any tension in this whole structure. The whole thing is dictated by what is called as a pure compressive stress field. Okay. Just the opposite of that is all those catenary kind of cables which are hanging. So catenary cables get into a pure tension. Here is a case where it is getting into a pure compression. This is how the traditional knowledge or the conventional wisdom, I will tell, has come into the play of all those things. It's much more. I just listed only one as the geometry, but there are quite a number of them. In fact, the recent challenge we posed to some of our engineers is, how can I have a 1,000 years old concrete? Okay, the concrete that you see, which is a very good material, you can mold anything out of that. You can do a 3D concrete printing and all those things, has got a life of 100 years at best. We have not seen it, but all those oxidation process, a mineral goes through a cycle. Shika, actually what happens is when you take a mineral and drive out the oxide in that, you get the pure mineral, right, iron. And then the natural process brings it back to the oxidation and goes back to the hematite or whatever be the kind of mineral it was. That's a process that is going to happen. So despite that process, what are you going to do is the challenge that you are going to have. See, let me tell you the scenario being done. If you take the case of California, you are asking about the earthquake. The whole Justice Court or an important building in an earthquake-prone area is totally being removed by part and reassembled somewhere, or it is cut and isolators are getting introduced. Isolators are very soft materials. So that's the kind of thing that we should aim at. Let me tell one more and then finish it. Even if you have to digitally create a structure, LiDAR is right now extremely expensive. We evolved from a process called photogrammetry. You take 2 or 3 photographs of the different angles, 3-dimensional angle, and similar to what the eye does, eye is doing that kind of stereo thing through 2 of your eyes, and then you can beautifully construct that. That's a relatively less expensive way of doing the whole thing. So we should have a relook at some of those things, as well as the LiDAR cloud kind of thing, and then go on there. So that will create a kind of scenario here where a lot of jobs will be created. With the kind of heritage available here, we will create extremely good amount of jobs because we appreciate the traditional wisdom of our previous builders who created structures which are standing for 1,000 years or 1,500 years. That's the kind of thing we have to borrow upon, and a lot of knowledge on petrology of the rocks. What is the internal, how the rock itself is formed, such that you get the grain size of the rocks or the crystallography of the rocks. All those things have to be examined from the scientific viewpoint. Yeah, I'm done, Shika. Thank you.
Yeah, so sir, thank you very much. We have one viewer connected, architect Shabi. So he is an urban regeneration specialist and wants to know the role of community participation in conservation and restoration. So Mittal sir, if you can respond. Role of community participation in conservation and restoration.
Actually, I will address it to Architect Shabi. In fact, this is a area, the kind of vast problem, as Dr. Gopalakrishnan just told, even in Tanjavur, you have 40,000-50,000 of monuments. How government can maintain all these things? It has to do with education, roads and other things, hospitals. So community participation is one of the very important thing. I touched in my earlier address also that we have to develop a model where community residing around that heritage structures feels connected. We can initiate some soft programs so that they are aware about these activities, and then these connection under CSR activity or in the community participation activity, they can maintain and enjoy the glory of that heritage structure is a very good area. We in India, at some places, people are doing it. Some of the temples in the city, they are maintained by private societies. There are no government aid is there. I myself am associated in 2-3 mandir samitis of Roorkee. So we get funding and nothing is there. After 50 years, they will qualify all to the heritage structures. So similarly for the old things also, old havelis, old forts, people are converting them to hotels and other. So their community participation is also a very good idea. We should promote it, and we should try to think and means how community around that monument can be sensitized towards it. So it is not, there is no vandalism on the monument and things like that.
So very rightly said, sir. So thank you. We'll come to a conclusion of this session now. Thank you everyone for connecting with us and for your talks and comments. It was great listening to all the panelists today and was very fascinating to know about the methodologies for conservation and restoration of heritage structures. So we have almost reached the end of the session. I once again request Director Cbri, Dr. N. Gopalakrishnan, for delivering the closing remarks for the session. Sir, please. Sir, please unmute.
Sorry, Shika, it's a very well conducted session. I was on and off here. So my sincere thanks to Jammal Saab as well as to Mangesh. And then from the headquarters, you have taken, you have turned, no stone was unturned, and then you have done all the things such that in the long list of the success stories, one of the success story of CSIR Cbri also is added. I'm very, very grateful to all of you from the headquarters team. And again, Achal Mittal and his team, Dr. Achal Mittal, Dr. LP Singh was not here, and then Dr. Devdatta Ghosh and all his team have made a wonderful presentation. Thank you very much.
Thank you very much, sir. And for all the viewers, we have a blog posted on our CSIR website regarding the topic today. So you may have a look. So thank you very much. Closing the session now.